I will discuss about the reaction of halogenation. So halogenation, a typical example is the benzene is treated with the chlorine in the presence of FeCl3 or anhydrous AlCl3 to form the molecule chlorobenzene. Or another example, the benzene is treated with the bromine in the presence of FeBr3 to get bromobenzene. These are the example for what is so-called halogenation reaction. Now we will discuss about the mechanism of aromatic halogenation. See, the reaction is quite simple. It's a generalized format. So first one is a generation of the electrophile. Remember, the electrophile here is Br plus, the bromonium ion. See how the electrophile is generated. See here, this molecule is simply bromine-bromine sigma bond. This bromine-bromine sigma bond will break in the presence of FeBr3. This is a Lewis acid, so this will attract this pair of electron so that this becomes slightly positive in charge. So this bond can be broken very easily to get Br+. Br+ is the electrophile. Now once electrophile is generated, Br+, now it will bond with the benzene ring. So how it is possible? See, you can see this pair of electron will be shifted towards this carbon. So this carbon become electron rich, and where the Br+ can be added. So here the Br+ is added. Now here is the hydrogen which is already existing. Remember, all the carbon contain hydrogen also. Now since this electron is shifted towards this carbon become electron deficient, which is represented with the positive charge. And now this pi electron will be shifted between these two carbon so that this carbon become electron deficient. Now this pi electron is shifted between these two carbon. So the electron density is moving towards the positive charge. That's happening. Now this carbon become electron deficient. Now this is the resonance hybrid called the sigma complex. Now the last step is this one. So here you have the nucleophile or the base Fe minus Br4 minus. So that will take up an H plus from here. Now this excess electron will be added towards this carbocation or sigma complex to get the product. Okay, so that is a final product, bromobenzene. That's a mechanism of what is so called aromatic halogenation. Now we will discuss about the next reaction. Now the next reaction given us. Next reaction is nitration. So what is nitration? The benzene is treated with the HNO3 nitric acid and sulfuric acid to get nitrobenzene. That's the reaction. Now here the generation of electrophile happens in this way. The sulfuric acid reacts with the nitric acid, and whenever the sulfuric acid reacts with the nitric acid, what happens is an H plus from sulfuric acid is donated to nitric acid. From here an H plus is donated to here. That's why it becomes H2NO3 plus. H2NO3 plus. And since a hydrogen is removed from, not hydrogen, H plus is removed here, it becomes HSO4 minus. Now in next step, this H2NO3 plus will lose a molecule of water, H2O, and what is left is NO2 plus. And NO2 plus is called the nitronium ion, and nitronium ion acts as the electrophile here, nitronium ion, NO2 plus. Now remember, during this reaction, what the nitric acid is doing, it accepts an H plus from sulfuric acid. Here you can see HNO3, only one hydrogen, H2NO3 plus 2 hydrogen, which accepts an H plus. And you know, anything which accepts an H plus is called a base. So nitric acid accepts an H plus or a proton, and thereby it acts as a base here. And simply because whenever you have two acid, a strong acid, here it is sulfuric acid, that becomes the acid. So automatically the other species become the base. That's all. Anyhow, nitric acid acts as the base here, while sulfuric acid is the acid, since it donates H plus. And NO2 plus is the electrophile. Now what is next? This pi electron is shifted towards this carbon, so that becomes electron rich, where the NO2 plus is added. Now there is a shift of the pi electron, and after shifting, similar to what we discussed in the previous case, and it forms a sigma complex, and sigma complex is a resonance hybrid, can be shown like this. Now what is next step? Next step is the loss of the proton. And see, this is the way HSO4 minus will accept an H plus, and thereby the excess electron will be shifted back to the benzene ring, and thereby you will get the product called a nitrobenzene. So this is a simple mechanism of the reaction called a nitration reaction. We'll continue with the discussion.